Okay, so we're going now to do exercise 13D, y dash is equal to gy function, and it's called a logistic equation. It's another differential equation that we need to solve, very similar to the one we did before. So I'm just going to start with the actual process of solving it, and I'm going to try a few questions from the exercise book. That should be enough to cover this exercise. On a textbook, it says like there are two different ways to solve this equation. Y dash equals to g of y, so y dash equals to g of y. The first method they were saying is, regarded as a separable differential equation. So what you're doing here is change this one into, well, I'll just say first method. All right, so the first method is you actually change the y dash into dy over dx is equal to g of y, and then once you finish that is you're treating this as like a separable differential equation, which means you're moving this y function here to the left hand side where it has the y, dy here, move the dx over to the right hand side, so you can differentiate it, you can integrate it both sides here. Alright, so that's what you're doing, very similar to what we just did yesterday, and now you can integrate both sides. That would be the method. That's the first method. Right, the second method is, which I feel like, these two methods are just the same method here. There's not much difference here. The second method to do this question is you change the y dash into dy over dx. All right, and then you just treat this as like is equal to g of y, and then since on this side here the denominator is dx, it's x, on the right hand side is y, you kind of integrate both sides like this. You've got different prenumerals, so what you're going to do here is reciprocate both sides, so you get dx over dy, right, is equal to the reciprocal of g of y function here, and then you can integrate. Alright, so I don't see any difference, because if you look at this, the next step I can do is move the gy, okay, a dy over to the right hand side. So you end up with like dx is equal to 1 over g for y dy, which again, these are the same function here. So there's the same expression, there's no difference here. Well, in the textbook they said that's the two methods. Well, I would just say they're the same method here. All right, so it's up to you which way you like to use to actually solve the question. All right, so we're going to try quite a few questions from this exercise. All right, so hopefully those example question will be enough for you to understand how to solve this logistic differential equation. So let's just do example 1. All right, so the question says solve y dash equals to e to the power of y using both approaches. I'm just going to use the one approach, okay? So if that's the question here, the first step I will do is, the method I will use probably is the second method, all right? It's up to you which method you like to use. So I'll just do dy over dx is equal to e to the power of y. So therefore that gives you dx over dy, do the reciprocal both sides, that's e to the power of minus y. All right, so therefore, when you integrate dx, is equal to, when you integrate e to the power of minus y dy. So therefore, the answer here is x is equal to minus e to the power of minus y plus c for a constant c, okay? And remember, we still haven't finished the question. I need to make sure that, y is the subject. So therefore, the next step here is making y as the subject. So you can get to like x minus c is equal to negative e to the power of minus y. Then you can put the negative there, so that's minus x plus c is e to the power of minus y. Minus y is equal to ln bracket negative x plus c. So final answer, y is equal to minus ln bracket x minus x plus c, and that becomes the final answer for that logistic equation here. And that's how you solve it. Of course, if you want to find out what's the particular solution, all you have to do is to actually substitute a given condition. Then you will be getting the equations. All right, the actual equation. All right, so the second example I would like to try is very similar to the question we did before, but we never really introduced that as a logistic equation. We only sort of like covered in the exponential growth and decay question, and I still hope you guys remember this. Previously, we had a question where if it's an exponential growth or decay question, it's actually a very simple differential equation. But we never really used the word differential equation at that time. So we have a question like, dy over dx is equal to k to the power of y, or n to the power of, ky. I hope if you still remember this. K is just the growth constant or decay constant. All right, if k is positive, then it's exponential growth. Then if it's decay, then decay is negative. Do you remember that, we at the end, I think like last year, I still remember that I actually showed the way to sort of do it and to prove that y is equal to ae to the power of kt. All right, that's how we solve it. All right, and I hope you still remember this is an exponential function, and that's the exponential growth function that we sort of use to solve the question. All right, now today we can use the logistic equation method here to actually solve it, to prove from this to that, okay, to show that the solution of this equation is equal to y equals to ae to the power of kt. All right, so we'll use the same method here. There's not much difference. So dy over dx is equal to ky. I will do reciprocal both sides, so dx over dy is equal to 1 over k, 1 over y. Now you can integrate it, so therefore x is equal to 1 over k ln y here plus c. So at the end, x minus c is equal to 1 over k ln y. Now we can always move the 1 over k to the right hand side, sorry, to the left hand side. So this is what we're going to do. Move this one to the left hand side. You have a k here. So therefore your y is equal to e to the power of kx minus kc. Okay, now we can further simplify this one into e to the power of kx times by e to the power of minus kc. Now please remember this, that e to the power of minus kc is just another constant, so which means we don't have to write all of those. We can just put that constant, since that constant is times to that one here, so we can just change that into a e to the power of kt. Okay, that's the process. ae to the power of kt. So it's actually pretty easy now once we formally introduce the logistic equation, and that's not really hard anymore. Okay, all right, so it's a pretty simple and straightforward question. All right, let's have a look at an example, the next example. Okay, example 3. So we're going to solve this differential equation. Y dash is equal to minus 3y. And then we need to find the particular solution that's, given that initial condition or initial value y2 is equal to 50. Okay, so in order for us to solve this one, I hope you still remember from yesterday, this is very similar, or it's actually a separable differential equation. That's just the second case. You just need to remember when you're solving a separable differential equation, always first to check the constant solution. So there is a constant solution here. If we check y equals to 0, therefore the left hand side is y dash, which is equal to 0. The right hand side is minus 3 times by 0, and that's equal to 0. So y equal to 0 is one of the constant solution. Okay, once we have finished that, then we can actually start to solve this differential equation to find a particular solution where y2 is equal to 50. All right, so dy over dx is equal to minus 3y. Dx over dy is minus 1/3 minus 1 over 3 times by 1 over y. So x is equal to minus 1/3 ln y plus c. All right, let's put information there. We know that y2 is equal to 50. So when x is equal to 2, y equals to 50. So 2 is equal to negative 1/3. Okay, I'm pretty sure we need to put absolute value here. Did I put the absolute value previously? No, I didn't. Yeah, but if you look at this one, I think what I just assume that's positive. All right, it is actually positive, but I can't really assume. I'll sort of need to tell you why. So this is absolute value here. Now the reason I can remove the absolute value is e to the power of kx minus kc. Doesn't matter what is the power equals to. That e here is always positive here. So that's why you can remove the absolute value and changing the y to be a positive number. That is the reason. So if you want to do it properly, yes, put absolute value there. Okay. So that's 2 equals minus 1/3 ln 50. Plus c. Okay, so once we finish that, we can actually find out the answer for what's the value of c. Now, if you don't like to use this way of finding the c, what you can do is instead of finding a c and a substitute and rearrange, you can leave this step to the later step. All right, instead of finding c, you can find just the a in the front. All right, so I'll show you what's that mean. All right, so you get x minus c is equal to negative 1 over 3 ln absolute value of y. So negative 3x minus c is equal to ln y. Okay, all right, so therefore y is equal to e to the power of minus 3x plus 3c. Okay, and then we can simplify this one into e to the power of minus 3x times by e to the power of positive 3c. Alright, since we know that e to the power of 3c is it's a constant number, so therefore we can replace that constant number by a. So that becomes a e to the power of minus 3x. Alright, from here you can start to substitute the value and then find out what is the constant for a this time. So sub x equals to 2, y equals to 50, based on the conditions we have here, then we should be able to find what's a. Okay, so 50 is equal to a e to the power of minus 6. Okay, and then what does a equals to? So a is equal to 50 e to the power of minus, or positive 6 in this case. Okay, alright, so therefore y is equal to 50 e to the power of 6 times by e to the power of negative 3x. After we simplify by combining two e's together, we end up with minus 3x minus 2. Is that minus 2? No. Yes, if we have brackets. Okay, so that's it. That's how you do this question here. So we'll have two solutions. That's the first one particular solution here, and then we also have another solution when y equals to 0. Alright, so please always remember to check the constant solution there. Okay, alright. Right, so the next one I would like to do is where you have to actually use partial fraction. Now this is something that, if you haven't done an extension 2, then you need to, you need to sort of learn this. But, with question like it requires to use the partial fraction in extension 1, they're not going to ask you to do it straight away. They're going to give you what you need to know before they will ask you to do the partial fraction. So I'll pick a question from the exercise, okay, and you should be able to see what I mean about it, okay. All right, so so let's just have a look at a question. Let me find a good question to start. Let's have a look at questions 13 in the textbook. All right, so I'll write down this is an example 4. Is that an example 4? Yep. And then this is going to be question 13 from the textbook. So for the first question here, it says show that 1 over y, 1 minus y is equal to 1 over y plus 1 over y minus y. Alright, so as you can see here, this is a kind of like a partial fraction question, which the question asks you to show. So you don't have to use the 4-unit method where you have to write down a over another, a over a factor plus b over another factor, and then you do the cross multiplication. You don't have to do it this way. So the easiest way to do this is just start from the right hand side. Is equal to 1 over y plus 1 over y minus y. Make the same denominator. Okay, and you just do it this way, all right? And it's a very simple question, 1 mark, and you show that is equal to the left hand side, and it's good enough, right? It's a show question. It's only designed for the student who didn't do extension 2, but they need to know this expansion here so they can integrate. Otherwise, they can't integrate this part here. So therefore, the question, they have to tell them this first so they can integrate that function. All right, that's the only reason. Okay. All right, question part B. Now, question part B, it says, consider this logistic equation, y dash is equal to y, 1 minus y. First question, all right, part of the question here is, what are the constant solution? Okay, so what are the constant solution for this logistic equation? Solutions. Okay, and the second question here is use part A to find a general solution. All right, so I'm just saying find the general solution. Okay, all right, so to find a constant solution, again, pretty easy. That's y, that's 1 minus y, which is let each of the factor equals to 0. So when y equal to 0, we can check the left hand side is equal to y dash, which is equal to 0. The right hand side is equal to 0 times by 1, which is equal to 0. If y is equal to 1, We can also check this as well. Left hand side, y dash is equal to 0, because if you differentiate 1 is equal to 0, the right hand side is 1 times by 0, which is equal to 0. So we've got 2, all right, constant solution, which is equal to 0 and 1. Okay, next we need to find the general solution, and this is where we're going to use that, partial fraction to do it. Okay, again, it's not hard. If you have done the mechanics topic, you've seen this is very sort of like, standard question to do. Right, so y minus y. Okay, find the reciprocal of both sides. And here we go, that's the expression we have. As you can see here, this is an expression, and we need to change that expression into the expression here, 1 over y plus 1 over 1 minus y. All right, so dx over dy is 1 over y, 1 over y plus 1 over 1 minus y. Okay, all right, so now we can integrate both sides. So therefore x is equal to, now the reason it's actually called a logistic equation, as you can see here, whenever you start to integrate, you are going to get a logarithm function. Okay, that's probably the reason. All right, ln absolute value y minus ln absolute value 1 minus y plus c. Okay, all right. Still haven't finished it. We need to actually make a y as a subject. So we'll move the c over. Okay, we combine these two together. Alright, and then we get y over 1 minus y is equal to e to the power of x minus c. Okay, alright, let's continue. So that gives us y is equal to e to the power of x minus c minus y e to the power of x minus c. And we just need to, sorry about that, we just need to make a y as a subject. So move it to the left hand side like this. Okay, make a y as a subject. Bit crazy. X minus c. All right, and then y is equal to e to the power of x minus c over 1 plus e to the power of x minus c. Okay, that's what you get, and that is the solution. All right. Okay. Now, if you look at this solution here, I'm just going to write down this solution. I'm just going to copy this solution into the next page. Yep. Okay. If you look at this solution, one of the issue with this solution here is you've got the power, all right? You've got like a power x minus c. You've got a power of, x minus c on both the top and the bottom. So the way we sort of simplify this is we understand that we can change this one into e to the power of minus c times e to the power of x. We can do that. And then we can replace the e to the power of minus c. So we can say let a equals to e to the power of minus c. So we get a e to the power of x over 1 plus a e to the power of x. Okay, we can even do a bit more. All right, so we can actually divide both the top and the bottom by e to the power of a e to the power of x. Now the reason for that is we just make sure that in this expression there's only one exponential function inside, so it's just much easier later when we're dealing with other questions, and you can have a look at questions 13c and d. This is probably the reason why you need to do it. So we end up with 1 over a e to the power of minus x, okay, plus 1. Okay, so that expression here. So let's have a comparison of these two expressions. So that was the answer we had previously. Now this is the answer after we kind of simplify it. It becomes much easier to see what's going on. So they can ask you various questions, like for example, when a approaches to infinity, what happens? When a approaches to 0, what happens to this expression? When x approaches infinity, what happens to the expression? So this kind of question, so you can sort of do those questions much easier if we can change the question into this form, all right, into this format. Okay, so this is how you do this question here with the logistic equation. I feel like in the exercise, the question asked, again, pretty straightforward. There's nothing that's really requires you to do lots of calculation or yeah, but if you follow the method, it's not that difficult. Okay, just one more. I'd like to do one more question, example 5, before we finish this lesson. Now this question is actually pretty interesting. I will actually do this question like later when we actually start to do exercise 13b, the slope field, which I skipped it. All right, now this is the question where it says that we have, for example, y dash is equal to y 1 minus y, very similar to the previous one. So the first one is you need to prove that, okay, prove that y double dash, okay, is equal to y dash 1 minus 2y is also equals to y 1 minus y 1 minus 2y. Okay, so that's just the first part, and we'll do the second part later. All right, so how do I prove that? Okay, first step you do is you kind of need to use the chain rule to prove it. So this is what you need to do. All right, first step, you expand. Oh, no second derivative yet. Okay, you need to expand. That's y minus y squared. All right, once you have finished that, then you start to do the differentiation. So I'd like to just show the steps, all right? So y double dash here, so you differentiate again. What does that mean is you need to differentiate each function with respect to x, and that is the function in, with respect to x. So the derivative of y is just equals to 1, but with respect to x, so therefore we have to write dy over dx at the end. That is just the general. Minus the derivative of y squared is 2y, and then we times by dy over dx. Okay, so by doing that, we can now write down the y double dash is equal to 1 minus 2y times by dy over dx, which we know dy over dx is just y dash, and here we go. We got the solution that we need. Okay, that is just the first part of the solution we need. Once you get the first part of the solution, the second part is extremely easy. We know what y dash equals to. As you can see, y dash is equal to that. We can replace that y dash with the expression here. So therefore, y double dash is also equals to, I'll probably just write horizontally, like what the question is asking, is also equals to, replace the y dash, y, 1 minus y, and then 1 minus 2y. Okay, now remember that y times by 1 minus y is y dash. Okay, that's all. So that's just the first part of the question. The second part of the question actually tells you to analyze, or sort of like analyze the gradient and the concavity. Okay, so use the above result. So you're going to use the first and second derivative to analyze, and you need to use your knowledge from the extension 1, year 11 extension 1 curve sketching to analyze the gradient and the concavity of the solution curves. All right. Now remember, the solution of this differential equation obviously is another function, and from this function we should be able to analyze quite a few things for the actual solution curves. All right, so how do we do that? Well, we start with the first derivative function. All right, the first derivative function is y 1 minus y. Now from the first derivative function, there's a couple of things we can see. Firstly, y dash is positive, all right, for y that's between 0 and 1, if you think about it this way. For y that's between 0 and 1, that's positive, and then this is also positive, so that's positive, okay? It's going to be negative, y dash is negative for y that's less than 0, or for y that's greater than 1. Okay, think about it. All right, if y is less than 0, that's negative, that's positive, so you still get a negative result. For y that's greater than 1, then the first part is positive and the second part is negative. All right, so therefore that's still negative. All right, what about when y is less than how is that possible? We can have like both equal to a negative number. Let's have a think about it. If that's a negative number, then that's a negative number, so that's another negative, which means this is always going to be a positive. So in that case, you can't have both negative, all right, to give you a positive. All right, so anyway, what does that mean is for y that's between 0 and 1, y dash is positive means the curve is increasing. And obviously here, the curve is decreasing. All right, once we finish that, then we'll look at the concavities. All right, so y double dash is y, 1 minus y, 1 minus 2y. So let's have a look at concavities. All right, y, again, we analyze it this way. Y double dash is positive for y that's in between of 0 and half, or y is greater than 1. Now for some student, if you find like, how do you know this answer here? How do you even know without even drawing, like without even solving it? It's like solving inequality. Think about like this is just greater than 0. You're solving this inequality, and that's a polynomial. So you kind of like drawing a polynomial curve here. That's 1, that's half here. And then the leading coefficient is positive, so therefore the function goes from here, so go from here and it goes down like that, right? Then you're looking for which part is positive. Well, positive part is here between 0 and half, and the positive part is greater than 1. So that's how I get it. Okay, I just didn't draw the diagram, I just look at it from here. But if you want to use the diagram, yeah, feel free to use it. All right, the next one is y double dash is negative. Now from the diagram, it's actually pretty good. When you draw one diagram, you can solve 2 set of questions. All right, so for the second part is less than 0, so it's this part here, as you can see, and that little part is also less than 0. So that's for y that's less than 0, or for y that's between half and 1. Okay, so now what does that mean? If y double dash is positive, its happy face means the curve is concave up, and here curve is concave downwards. Okay, concave down. All right, at this stage, because since we haven't done the exercise 13b, so you don't know anything about the slope field, so therefore I'm not going to draw a diagram for you. Eventually, you probably need to draw some simple diagram based on this analysis of the diagram of the question. Okay, all right, so that's it for this lesson. Hope you enjoy it. All right, thank you.